Okay, so here we go. Start from the top there, Frank.
Yeah.
All right. Welcome back. This is Microsoft Virtual Academy Module 8. We're ready to go with Jumpstart for C#. We left off where we left our hero. He was talking about async and await. That is for those are the new keywords introduced to C# to handle asynchronous development. And we were. It's interesting. Asynchronous development, kind of, is a native piece for developers of Silverlight, wouldn't you say?
Yes. So basically, the Silverlight environment really constrained developers for the very first time to have to implement interactions with services as an asynchronous operation.
You say for the very first time. It was there, but it was just something that developers didn't get into.
But they weren't forced to. Yeah. That was it. Silverlight said the only way you're going to interact with a service is via an asynchronous operation. And that, as I mentioned earlier, is based upon the Netscape plugin standard that states that no browser plugin can actually hog the UI process for a browser.
The winner is truly the user, right?
Exactly.
They're interacting with your application because it's asynchronous now. We don't have to worry about the application freezing whenever you're doing some sort of long-running process. And so we all have long-running processes. Sometimes it's calling a service. Sometimes it's just crunching numbers. It could be just about anything. Often developers, in the past, would just kind of bite the bullet and they would just let it run. And you would see applications with the not responding at the top because they hadn't set that off and allowed and freed up the UI to continue. And so now we have asynchronous more and more being pushed at us. Of course, Silverlight, as you said, ushered it in to really kind of force the hand. And Windows 8 has done the same thing with the Windows runtime. The Windows runtime, very aggressive into asynchronous development as well. How can we make that simple from a C# point of view? That's why we see the introduction of await. That's why we see the introduction of async. They are certainly friends with each other. You wouldn't see them apart. Async is the keyword we would mark a method to say, inside this method, we're going to do some sort of asynchronous operation.
It's eligible for this pattern.
Yeah.
That by putting that on there, we're letting the compiler know you can expect there to be an await keyword, and we can expect you to be interacting with tasks within here. And it's kind of a hint for the compiler, okay, now do the legwork.
The actual asynchronous work occurs with await. Async is the hint, right, that it's going to be coming. It doesn't actually have to, right? You'll get a compiler warning, like, what are you doing? But at the same time, once it's in there, there's a wait that does the asynchronous work for us.
And you can have more than one await.
You certainly can. You can start stacking them as much as you want to. Where we would have built this scaffolding before without await and async, we would have had so much code and so much. It's not bloat. It's just what you would have to do, and you'd have to keep a very clear mind to be able to trace the flow and to, if this has occurred yet, if it hasn't occurred yet. Doing things in series, it would be very difficult. Actually, how you could have await.
Exactly.
Very
you have
difficult.
a lot of breakpoints all over your application based upon where the callbacks were being invoked.
Yeah, absolutely you would. Absolutely you would. And so. In fact, did you find this slide?
I did.
Okay, so let's take a look at this slide because this really shows the, not the old-fashioned, but the only option we had prior to await. And so this is a class that gets HTML using the web client. We've seen this sample before when we were getting JSON. And so you can see what happens is two things. In the get HTML method, it is spinning up the client, but before it calls to download it, it first handles the completed event. This is basically saying, go download it. I don't know how long you're going to take, but when you do raise this event, I'm going to handle the completion. And so when we do handle the completion, we raise our own event called completed. Now, I call get. If I'm the outside consumer, I'll call get HTML, and of course I'm going to also subscribe to completed. And who knows when completed will take? I mean, it could take a minute, 2 minutes, 3 minutes. Who knows what it'll take?
It depends how big the file is you're downloading.
Right, and it depends on what kind of processing I'm going to do to it as well.
What happens
is very simple.
Is get HTML will return immediately. And so we cannot assume that when get HTML completes that we actually have that data.
That's why get HTML returns void. There's nothing to give me, and it's not until I have completed that I actually get it back. That's very powerful, very useful. And it was our only option. It seems simple.
It seems simple now because we've only got one asynchronous operation here.
Yeah.
But say we needed to turn around and say, okay, go away and get the movie title information. Okay, I've got the movie title information.
Right.
Now go away and get something else else related to this movie, which again is going to be an asynchronous
and it's
operation.
ratings now.
Yeah, and then go away and get this. We'll have 3, 4, 5, 6 nested callbacks, all of which we have to create all the scaffolding, we have to create all of these environments. Then we also have a challenge. What if we want to kick off a couple of those at the same time?
Right. But not more than 3 at a time, not more than 2 at a time. Now it's a real pain.
You've got to do all of that management yourself.
Yeah, and so where we have, just for one asynchronous operation, we have to have all of that code. Now you start having 2, 3, and you need to have them in a certain series. It's very, very difficult. All right, now let's see what it would look like with the async keyword. So here's the same method, but and already you can see there's a lot less scaffolding. We don't need a handler. We don't have an event that we raise. And even better, the event itself returns the result. Very, very powerful. Of course, we didn't have to even have return HTML. We could have done this in 2 lines. Shoot, we could have done it in 1. Yes. We could have minified our own code, but what's the advantage of that? This method is different, and partly the reason it's different is because it is decorated with async, that warning or that hint to the compiler that we're going to do some asynchronous operation.
But wait a second. It looks like that method is returning a task of type string.
Yeah, certainly it's the task object that enables all of this for us. So we return back a task, and the reality is that's the reason we can release. We have already returned whatever it is we need to return, but it's incomplete. And so now I've returned whatever it is I need to. It's of type string, which means the resulting value is going to be string. But now the consuming client is going to wait for the task to be complete. So now the task can be completed, again, with an await keyword as well on their side. So now instead of having the complete, because remember we had the completed event here, and then we would have had a completed handler in the client in the previous demo. So now we don't have to have that. We would have a completed, we would have an await here, and then we would have await in the client. And we've dropped it down from 7 lines, 8 lines, to just 2 or 3 lines. And even more importantly, we can wrap it in a try, which you cannot do in asynchronous program in the standard way, right? Because you wrap it in a try, but you're outside of scope when your event is raised.
Absolutely.
That does not happen when you're inside await and async patterns.
So this is obviously a very brief and speedy introduction to something that is a very powerful capability, but we would have been remiss not to at least show you some of this code.
Yeah.
We clearly don't have time to dive much deeper into this, which is very unfortunate.
And it really is too bad because it is very important. And I think developers are hesitant to approach it because it feels complex, but it's not complex, right?
Yeah.
Let's go into other common tasks. We know that asynchronous now is going to become a common task. Another one is just talking to data sources, like a database.
Accessing a database.
So a database, I think most of us are going to know what a database is, but just for the fun of it, Darren, what is a database?
So, database is, at its simplest, it's merely a data store. Now, it's a system that provides a way to interact with data. It allows us to store data in a more structured way than we would typically do. Say, we talked about writing it out to a file system. You know, a file is effectively just a bunch of binary.
It's a blob.
That you throw data into.
That's right.
You know, any structure there, you interpret and you place based upon how you interact with it. It's not defined within the file itself. Within a database, you have the ability to create tables, you have the ability to create columns within those tables, you can apply types to that, and so it's very rich.
What's great about structured data is that it's reliable. You know how it's going to be laid out, you know how to get it, and because it's reliable, it also can be optimized. And so you were saying it gives us a way to query it and allows those queries to be very performant because it knows about the data, how it's going to be used, and they can also apply indexes and other strategies to make it even faster.
Basically shortcuts to jump to the correct place in the file.
Yeah, you're absolutely right. Now, databases themselves, I'm at a disadvantage.
Oh, you have a problem.
After you.
Okay, do you want to pop up the slide on the screen?
There we are.
So, databases, what databases can we use?
Well, there's a lot of them. Only Microsoft databases. That's not true, of course, right?
True.
No. The databases that we can talk to, of course, are ones out in the cloud. You know, we could have a database that isn't here for us locally, such as Windows Azure SQL database, where we could talk and store that data so they could be shared across clients, and so that we don't have to worry about backup performance and things like that. Very nice. A local network, something inside our environment. Also a local machine, so I could have SQL Server installed on this device, and I could interact with it just as I would if it was on my network, on my local network. And then we also have local DB, and of course local DB is new to SQL Server, slightly new to SQL Server. It allows me to, I will leverage SQL Server Express, but it allows me to deploy that database with almost no setup inside my application. And then very powerful and very cool, SQL CE, that's the compact edition of SQL, that basically allows me to ship all the runtime necessary to host it, to query it, to make it performant. SQL CE is a neat way to have a very easy data store inside a C# app. Perfect. Or a VB app, frankly. The way that you would talk to a database varies, right? You might talk to a database manually, and there, of course, all of the namespaces are there. You can do that the way that you want to. You can talk directly to it, very, very raw. You don't see that as much as you used to.
Just really using ADO.NET.
ADO.NET is that namespace that gives you everything, that data reader, the database connection, all those objects that you need. But we can wrap those as well to not just simplify and increase productivity, but sometimes to abstract it away as well. And so those are usually object relationship models, ORMs, and ORMs are very popular. You see ORMs all the time. The likelihood of somebody doing a raw call to a database is not unheard of, certainly not. It's very performant, and that's the reason you might choose it. But at the same time, a typical application is going to include some sort of ORM. Microsoft makes one. It's the Entity Framework, but there are certainly others out there like
Hibernate,
and Dapper is there. Dapper is very performant. And yeah, you're right, CSLA. One of the benefits of using an ORM is that it does allow you to do conceptual modeling of the data, and basically it's a bridge between the way you want your classes, the way you want your objects to look in code, and the way they really are stored in the database may not be one-to-one. So you can do this kind of mapping so that everything goes the way that you want it to.
Yeah.
And then the ORM allows you not only to read, but also to write, so that mapping can go both directions. Very powerful.
Yeah, you may find that there's a disconnect, an impedance perhaps, between the way that your application will view the data and the way that the data should be stored in a relational model for optimization purposes. And so by having this intermediate layer that allows us to take our concept of how the object should be modeled within our application domain and map them to a third normal form that may be expressed within the database itself. Now, clearly what we're focusing on in this section is really talking about relational databases. There are a whole class of other databases out there, such as Mongo and those kind of things, that are the NoSQL type of databases and those that are really document-oriented. There are many frameworks available to leverage those inside the .NET space, but we won't be touching on those today.
Those are sort of opened up to us by the provider pattern, a very cool pattern that basically says, it's a database, I don't know what a type, and then you can start creating the provider that's that in-between section that says, yes, it's a database, this is a SQL Server database, and this is how you're going to access it. I interact with just that interface, and all the direct conversation with SQL Server is kind of abstracted away from me. Encapsulated, no doubt about it.
Sure. Why don't you show us some interaction?
Yeah, this is great. Let's create an application here. I've got my console application running here, or loaded. Doesn't have anything. If I were to open up a program, it's empty, right? I am going to, let's do some, I want to create a database. So the easiest, without a doubt, is to ship a database with it, nothing to install. I don't have to worry about the service, the version, or anything like that. So that's going to be SQL CE. So what I can say is add new item, and from here I can say data. And so I'll filter data to see all the different options that I have, and I'm going to select local database. Local database is an SDF file. SDF is just the extension for SQL CE. And so I will select that, and as soon as I do, it adds the file you can see over here, database1.sdf, to my project. And what's great is from this point forward, it is part of the project, ships with it, it's all there, all of the DLLs I needed in order to make it work become referenced inside this project, and they all go together. It makes it very reliable. Now, to be fair, SDFs or SQL CE databases are not the same as SQL Server, right? There are things it cannot do. There are sizes it can't take, right? And I mean, it's not
Number
the same
of concurrent access.
Robust, right? It's not the same robust as a real full-fledged RDBMS that's installed somewhere.
And,
but it really gets the job done on application data.
Absolutely, yeah, and also, you know, other things that SQL Server can maintain is obviously spreading that file across multiple spindles and so on and so forth to really give you the performance to interact with large volumes of data.
There's only so much you can do to really improve performance of SQL CE. And having said all that, let's put it together. So the first dialog that comes up, because I added it, is the ability to add an entity data model. This is part of the entity framework. That's what the ORM that Microsoft has put together. And so I'll go ahead and select it. And when I do, it says, okay, you're going to create an ORM model. That's great. What is that model going to be based on? It's going to be based on, in this case, the database that we just added. And so here's my SDF that I can select. And as soon as I do, it's going to ask which tables inside that database. Now, before I can do this, I have to go in and create some tables because this database is empty. If I go through and create a data model, it's totally insufficient, right? I mean, we don't want to interact with an empty database. So I'm going to cancel out of this, both. And I'm going to right-click the. Oh no, I'm not. And I'm going to go to View Server Explorer so that I can interact with it. Here's my database right here. I can say refresh, and when it does, you can see the little green that shows that now it's connected to it. It's pretty nice, the little sniffing to find out that it's in my project. And I can look at the tables. There are no tables, this is what we'd expect. And look what it doesn't have. It doesn't have views, doesn't have stored procedures, doesn't have so much. It does have indexes and basic query syntax. And so I'll right-click and I'll say I want a new table, and this is going to be for, let's say, products. And now I've got a products table, and I want to create a few columns in it. I'll just create, real quickly, an ID. It's going to be, we'll make it a number, and a number. Bam, bam. Oh man, no. There we go. And then we'll give it a name. I don't want to make it too complex because you'll create the database that you want anyway. I mean, let's just be honest. I'll set this to be the primary key. I'll say a primary key has to be unique. And life is happy. There we go. That's a very simple database table.
It's about as simple as you can get.
It really is. You can see it's here in the tree. If I expand it out, I can see where the columns are. I can right-click it and I can say open the, or show table data. This gives me the opportunity to say, you know, I can have gloves, gloves. And 2, I could say scarves. 3, I could say coats. Give me another one. 4, I could say
lion.
Lion. Obviously, there's a pattern.
We've missed our animal meme here.
There's a pattern here.
We've missed our animals here.
Lion fur. The hat.
Oh dear.
Oh boy, that is.
Yeah, let's move on.
Certainly sounds awesome. All right, and in 5, you know, the last maybe boots. All right, there you go. So these are the products that you may have, and whatever it is you might have. Okay, so I'll close this out. It's updated the database for me. It's still over here. This was just my pane to interact with it. Now I can create an entity model. So I'll right-click my project and say Add New Item. And when I do, I can ask for it to add an entity model. This is me just repeating the same operation that it was going to give me in the first place. The there we are, got it. ADO.NET Entity Data Model. I'll say go, and when it does, just like before, it's asked me from what. I'm going to say this is from the database 1. I'll say next. When it does, now it's going to list the tables and say, which ones do you want to include in this model?
I think we should include products.
I think if we don't include products, this is not going to be a fun demo. Right, exactly. I'll go ahead and say finish. And it's using T4 templates. T4 templates are very powerful. Earlier we were talking about code generation. That's how you do code generation inside .NET. It's with T4 templates. They're all done behind the scenes for Entity Framework, but you could create your own to build your own.
Are you speaking so fast now? Just squeeze this in?
Yeah, I don't want to miss it. I do not want to miss it. All right. So here's the model. This is the beginning, right? I could make different relationships and define them. And this is the code model, not the actual database itself. And so I'll close out this model just because I don't want to make any changes to it. Like so. It'll ask me if it wants to run the code generation behind the scenes. And now it's done. I mean, what I really mean is now Entity Framework has all the information that it needs, both to reach out to my database and to query it. And so let's do that. So here we are. I will. So here's my console application. If I were to run it right now, black screen. So let's give a little functionality to it.
Sounds like a good plan.
All right. The first thing we need to do is recognize that the Entity Framework uses a context in order to talk to the database. So you create a context, and from that point forward, the context sort of handles all of your connection operations. So I would say var context equals new data1 entities, right? That's what we called it. I would have picked a much better name if I were
Revisiting the demo?
If I weren't clicking so quickly. What it also allows me to do now is now I can interact with the products, not just as if it's a table, but as if it's a class or an enumerable of products, which is really valuable. So now I've done the context. I don't have to say context.open or anything like that. The rest is handled for me. So now let's go get all of those products. All right, so now this context.products will return the enumerable of the products.
Wow.
And I can do some fancy stuff here. I can do some really fancy stuff here. We were talking about predicates before, and I can actually inject a predicate right here using a lambda statement. And we had talked briefly about lambdas in the second module, and how lambdas allow us to define a predicate with shorthand. And so lambdas are that shorthand. So let's go ahead and do that. I'm going to add a where clause, which is what you would really probably want to do.
So what is the where clause?
The where clause, just like in T-SQL, allows me to interact. So Entity Framework will take a lambda where and translate that into T-SQL for me, allowing me to interact with the database as if I'm typing SQL to it, but it handles all that translation. What's beautiful about it is it also gives me compile time checking. So because I treat these as strong types, not as just strings or objects that come back, but I treat them as strong types, I can also have compile time validation on my where clause, which of course you can't get that in SQL Server. Yep. That's an interesting benefit that you can get. But don't be misled, that benefit does have a cost to it, right? Yes. Because of that, we have to use an ORM to do it, there is going to be a performance impact. But sometimes that performance impact is negligible, and sometimes it's acceptable because you want to add the productivity of being able to leverage it.
And the other thing, where is obviously an extension method that forms part of LINQ.
It totally does, yeah. And so we'll talk about LINQ here in just a second, where LINQ has a series of extension methods that give you all sorts of manipulations against enumerables like products.
Sounds good.
All right, so now just to do it for fun, let's create a for each loop and loop through all the products and output their name. So now it's going to be item.name. That's pretty nice. It's kind of cool that I could say dot, and of course I call it item here because it's defaulted, but I could just change that quickly to product. Did you see that change down here as well?
Yeah, that was awesome.
Symbolic renaming inside Visual
Studio. Oh, that looks
Studio.
like refactoring to me.
Yeah, only the compiler can do it for us. I mean, it truly is a magical thing. All right. It is certainly refactoring, but that's not just a rename. It's not a find and replace. That is symbolic renaming, finding objects that reference it. All right, so now I can say object dot or product dot, and when I do, I can see that ID column that we called, and I can see name. Of course, I can see those other methods because just like everything else, this inherits from object ultimately. Fascinating. All right, so now I can go ahead and select name. Now when I write it out, hopefully this will write out a list of all the products in the database.
Yeah, it'd be disappointing if it doesn't.
In fact, it makes me cautious to do it. It would be so disappointing if it doesn't. I'll go ahead and do it because I'm pretty confident. Oh, look at that. Look at that hat. Looks nice.
It does.
Doesn't it?
It does.
Lion fur. Awesome. It's like a dodo bird omelet there. That's nice. All right, so the so here we are. This is a simple operation of read, but let's look at it for fun, and let's say only let's see. Good. Only products that have the letter O in them will be returned. So now I can add that where
predicate.
That's
a real world scenario.
Yeah,
I do that every time.
It really is. I would say, price is greater than or something like that, but we've only got 2 columns. So I'll put it on a second line just so we don't have to look at it and implement the lambda. This is the lambda right here.
Okay.
Interesting little syntax for sure. Certainly, we were talking before about takes a lifetime to master. Lambdas don't take a lifetime, but it does take more than about the 3 minutes we will give it credence right now. So now I can say X, of course, is going to represent an individual product.
So that is like an argument that's being passed into the lambda. Yes, it is. Move on.
Yes, sorry. Right, where the lambda represents the entire expression tree, and this is the argument portion, yes.
Exactly.
I was typing at the time, I apologize. Yes, earlier I was just being contrarian. This time I was truly baffled. All right. So now it's exactly the same as before, but this time I do have this quick little where I say the name has to contain a lowercase o. Right? And of course, like you pointed out before, I could make it ignore the case if I wanted to. And so if I run it again, now what we don't see are scarves. We don't see scarves. No O in scarf.
No O in scarf.
As far as I know. And there might be in other languages, but That's not where we're headed. Okay, so now we've added an interesting little predicate, but what's allowed us to do, you cannot talk to SQL or SQL CE with a predicate like this. You have to talk with T-SQL. This really does output the T-SQL necessary to interact with it. It's nice how it's abstracted away so that I don't have to do that. In fact, I could write an entire database-oriented application and never learn T-SQL because I can allow the ORM to do that for me. That is a common scenario. You find developers who just don't know how to interact with a database. It's sort of sad in a lot of ways, more than it is a compliment. It is interesting that the ORM enables that, but I think the goal is so you can have this sort of checking at compile time.
Absolutely. And part of the features that enables this to happen is the fact that LINQ, as we mentioned before, the compiler will either compile it straight into code that is executed, or will build it into an expression tree. In this situation, because we're interacting with the database, it's actually building an expression tree that the SQL Server provider for Entity Framework then evaluates that expression tree and translates it into SQL for us.
It does, and it's pretty neat. And so if I had there's a lot of power there. You know, there's a lot of controversy here as well, because the SQL that it does create sometimes is not optimal. And if you have a lot of data, if you're scaling very, very large, you're going to have to address that. You're going to have to look into how you can change performance. Sometimes it's as simple as calling a store procedure instead.
Yep. For those of you who work with DBAs on large projects or in environments where there is a separation of roles that you don't have access to the database and so on, they will be seeing the types of queries that come across, and you may get hit with a question from a DBA. Why are you doing all these inner or outer joins and so on and so forth? Here's a much more refined query you could be passing to the database, and that's where you need to work with them in terms of perhaps, as Jerry mentions, encapsulating that query into a stored procedure so you can leverage it in a more optimized way.
So in the first block here, what we do is we go get all the products from the table and then we iterate it. Here I'm going to just get the first product, and this will be important because I want to do some fun things with it. And so let me let's see. Let me just run it so I can show you what it looks like and make sure that we got the right one. You can see we got the first 4 filtered out, the one that doesn't have an O, and then we go and get gloves, right? And so that's the first one in the list. Cool. And it's pretty nifty because I'm able to use first, another extension method provided by LINQ. And you know what I would otherwise do is be able to maybe ordinarily get it like this, but I can use first, and it also allows me to add a predicate inside the first method, so I can apply a filter there if I need to.
So you say, give me the first one that starts with lion.
That starts with lion. You want me to do that?
Sure, why not?
Oh my gosh, it's so cool. X.name starts with lion.
And so this is the other real power of LINQ, is look how readable that is. Once you get in your head exactly how a Lambda works, you can look at this in pretty much in plain English. Say, I want the first product that name starts with lion.
It's really powerful. There's no getting around it. And so now I'm not saying first in the list. I'm saying first in the list that obeys this predicate.
Yeah, that's awesome.
And so let's run it again. And hopefully it'll say lion. Was it capitalized? I just can't remember all about C. Beautiful.
Yes, it was.
All right. So that works nicely. And now let's make some changes. I kind of meant to say not lion fur. Faux lion fur. Oh. That's what I meant to say. And so here's what I can do. Here's the product. Here's the product.name, and I want to make an actual change to it. And so what I'll say is this equals faux lion fur. You totally spelled that wrong. You know what I mean? And so now changes the meaning of everything. All right. So whoops, I don't need this. So now I've changed the class or the object that represents the data in the database. What's beautiful now is Entity Framework allows me to write that back. And so now I'm doing full backwards and forwards communication with the database. So now I can say, and everything is done inside the context, I can say context.saveChanges.
So basically your context is doing some dirty tracking and knows that you've modified that record, and so now you say save changes, so that's going to save all changes that are currently pending within the context.
It really does. And so now I can recreate products again, query the database one more time, and say for each product, forget about this business for now, and just write them back out, and it better say faux fur.
It better say it.
It had better say faux fur. And that will show us that it has saved back. I mean, it's really neat. All right, so let's go ahead and run it so we can see it. It spit out the list. It showed the first one, lion fur hat. It requeries it, and now it's faux lion fur hat. F-I-R. Turned into a tree by mistake.
Yeah, not only is it a fake lion.
It's as fake as you can get. It's faux everything.
Exactly.
It's faux fur. It's not a real pine tree. You just... now, oh gosh.
Now, let's move on.
Yeah. All right, beautiful. Let's do one more thing, just to show the full database interaction. I could also create a new product, by the way, and I could inject it, but let's go ahead and delete it.
Why don't you delete that crazy fur?
Let's delete it, because this is nuts. I don't even like it anymore. All right,
exactly.
So let's go ahead and delete it, and we'll do it like this. I'll say inside the context, I have my products table, and here I need to, there we go, remove, and then it's asking what it is I want to remove. This will translate then to the SQL delete statement for me. And so I'll pass in the prod, which that's the faux fur. And then just like before, I'm going to need to save this change. It's not going to do it just yet. And the reason it doesn't, I might have a lot of operations and I can batch them together this way. So now I can say
that's
context.
For efficient communication across the SQL Server.
Yeah, it's for, well, it's probably better to say it's for more efficient.
Okay.
Who knows if it's going to be efficient? We are at the mercy of an ORM. We do need to remember that. I use this, by the way. I have no problem including Entity Framework in a project, but you have to do things in measure.
Yep.
And so now I've saved it. If I were to read it yet again, and I'm going to just add a space this time. There we go. Now I'll add a little line, and I kind of wish I had done that here, because you know how they all kind of blur together. Anyway, so here it is. I remove it from the table. That's the way I indicate that it needs to be deleted. I'll save it. That delete statement will run. Now we'll just go get it again, and lion had better not be in that table.
Yeah, certainly no fur.
Certainly no fur. Now, we've got a small problem in that our predicate will never be found. We renamed it so it doesn't actually start with lion. So if it's all right with you, I'm going to just delete that. So we just take the first one and change it to, instead of starts with, we'll just change it to contains. What's pretty neat here is I'm using these string manipulation pieces that we talked about before, and all the standard stuff inside the .NET framework. So I'm not having to learn yet another language. I can learn what I've already learned and be able to apply it, but this time into a different context. So if I run it here I get them all, and then here I operate in between these two. I conduct the delete, save that delete, and now you can see I've returned all 4, and lion is no longer present. That's really, really nice.
That's really awesome.
Yeah. Running it over and over again actually created a second one. That's pretty humorous. But nonetheless, this is the syntax for updating data, querying data, deleting data, a lot of power. Entity Framework is right there. You can add it to almost any project. And
now, obviously, this has been a pretty trivial exercise in terms of we have a very simple table, and we don't have any relationships out with other objects. You can create a very rich object graph where you have dependent objects that could come in as properties. If you have one-to-many relationships, then they would be a collection of those child objects. You could bring those in. You could specify that they're lazy loaded or they're loaded in advance as you bring back. There's an awful lot of power there, so I really encourage everybody to go out and have a look at those things. But as you can see, it's very, very simple and straightforward to do this initial kind of interaction with Entity Framework.
Other things that you get for free are LINQ. So LINQ is the language integrated query language, which is basically when I need to iterate with or interact with something like a list of products. We showed how we can say .where, and there's so many other things that you can do, and they're all really given to us by LINQ, and it's right there, part of the language, and it can be extended so that it can talk to SQL Server if you want to, but at its foundation, it's linked to objects. My ability to interact with the objects that are right here with me, to filter them, to be able to project them, all kinds of neat things. Let's kind of go through the power of LINQ. One of the things I get, of course, is IntelliSense. IntelliSense allows me not only to kind of discover, but also not to get it wrong, right?
Yep.
It's hard enough to write some of these predicates, let alone not to have IntelliSense on your side. Absolutely brutal. One of the things that LINQ includes is is the ability to traverse down into deep objects. So this was very simple. It was just a list of products, but sometimes products can have children of their own. And you could have invoices, and invoices have payments, and payments have customers, and it could go on from there. I can do all of that with just using LINQ syntax. Now, LINQ syntax is complicated, and it would take a while to really get proficient at it and become very fluid in writing it. But once you are, it really opens up your code to a lot of possibilities. And if nothing else, it collapses your code, where you may have had line after line, loop after loop. I mean, how many times have you written
That's
a bubble
the key for
sort?
me, is because all of these things are operating against collections, fundamentally, things that implement IEnumerable, you can condense a lot of scaffold code, to use a term you talked about before, into just these very simple expressions that are doing all of the work behind the scenes. You're delegating, again, that activity to the framework and to the compiler.
Yeah.
We love the compiler.
The compiler does a lot of work for you. LINQ behind the scenes is just blown out beyond belief. But that talks to its power, because had it not done that, you would have had to have written all of that insane. And so not only it is often repetitive, right? But it is just another opportunity for you to get it wrong. It's just another opportunity for you to not do a bubble sort, for you to not do and oh my gosh, it really is complex, right? If I were to say sort by this, but then by this, but then by this, but not if it contains an O, right?
Yeah.
Wow. I mean, you've really asked for, you've basically given a developer a week's worth of work, where I could do the exact same thing in the wink of an eye now.
Sounds good.
Yeah. And so we have a demo actually put together to kind of show it off. LINQ comes to us in two flavors. It comes to us as a query syntax that sort of does feel like SQL Server, or I mean SQL, T-SQL. Sort of, right? The fact that it doesn't match it exactly it makes people frustrated. And so it's better not to, it's not like SQL at all, but it is kind of like SQL. So if you know SQL, you'll at least have a head start. But it also comes to us in a method syntax. That's basically all we've really shown so far. .where, .first, something else we did early on.
Exactly.
And let me pull up the demo, because the demo shows that it doesn't just give us the ability to add predicates to it, but it also gives us the ability to add aggregates and really powerful pieces that really would be difficult. I mean, just figuring out the average of something is hard, right?
Yeah.
I mean, if you think about not having these at your disposal, the average, but only even numbers and only the ones that are available in certain aspects. So let me close out this demo and open up the LINQ demo. What number is it? Do you know?
33.
Thank you. Thank you. Oh, it's an 8. Here we are. Beautiful. Bam, bam. Got it. Okay, so let's take a look. So enumerable.range, it's just a helper that returns a list of numbers to us. So you can say enumerable, that's just the namespace. .range, that's just a static method that you give a low number and a high number, and it gives you everything in between. It's nice, especially for demos like this. So now we have data, and it's just a list of 1 to 50. And so here I am using the method syntax. Pretty neat, right? So I can say data, that's my same object right there, data. .where, and we showed how we could include a predicate when we were interacting with the database. Exactly the same here. This is lambda syntax, where I say x lambda, and then here is the actual predicate itself. And so in this case, I'm saying whatever the object is, x is the represented piece.
So just to refresh people, a predicate is effectively something that returns true or false. So what we have here is we're passing in the value of x into the expression that is being evaluated, and x would be the item, the current item from data. So as it moves through, iterating through data, x is the current item, and then that gets projected into the predicate there, which then returns true or false if the number is odd or even.
It does. Yeah, that's exactly right. Good job. All right, so but then we get one extra piece, and that's down here in select. And you would think select is somehow the filter, or what columns you want and things like that. But what it really is a projection tool. And so projection is an interesting word that a lot of developers don't use in this context, and they don't necessarily doesn't have any meaning to them. Projection really means to create a new type or take the data and project it into a new type or a new structure.
Yeah, it's basically changing the data's shape to a certain extent. So that's the other major type of Lambda, is the projection. And so here we're taking the input, which is X, and we're transforming it into a string.
That's right. It starts off as integer, and here it's going to become a string because I'm doing this. Now I could also create a full class in this. I could say new whatever, and I could pass this as part of its properties. I could even create an anonymous type here. And again, earlier we were talking about anonymous types. I may only use them for a line or two, and so it's a handy way to store data and shape it the way you need it for your operations. Excellent. So I could do all three here. I could just return a simple type like this, an anonymous type, or a fully defined type. Okay, so this is the method syntax. Very nice, very easy. This is the query syntax. Does the exact same thing, just as easy, I'd like to say. Maybe more readable in simple formats like this. So it goes like this: query equals, and it's from D in data, and that's where I am actually defining that D is going to be all the items in data, where D modulus 2 is 0, so that's saying only the even. And what I'm selecting, just like before I project it out, I select d.toString. The results that go into method and the results that go into query are exactly identical. One just uses the method syntax of LINQ, one uses the query syntax of LINQ.
And one quick pointer, if you're first starting to work with LINQ itself, is sometimes you might start typing out this syntax, and you might start seeing some compiler warnings and so on. That's probably because you don't have the system.link namespace included in your using.
That is a good tip.
That is a good tip.
Yeah. Especially things like .where, you have some sort of enumerable, you say .where and it's not working. Yeah. You got to manually go up, say using space system.link.
Exactly.
Yeah, and then it works.
And then it works, as if by magic.
As if by magic. Excellent. All right, so let me go ahead and set this as the startup project, so we can kind of debug into it. It's kind of fun.
Oh, debugger.break, that's a handy command.
It is neat, isn't it? That's to make sure that it breaks there. Sometimes I'll put debugger.break in my catch statements. Yeah. That way I know that when it goes to release and into production, it would never do that, but it would cause me to always see some sort of problem. Right? It's really nice. Because it's debugger, the compiler, our best friend, will take that out when I go into release.
So that's hard coding a breakpoint. Awesome.
It is. It's hard coding. It is awesome. Exactly. I can't turn it off.
Yeah, how scary is that?
It's not scary. You're so easily scared. All right, so we can see data. All it really is a list of numbers, just like we would expect. Here's query. All it is a list of strings. You could see that because it has the quotes.
So there's an interesting feature of LINQ that you just exposed there. The result wasn't populated at the time when you brought that up, and there's an interesting aspect to LINQ.
Awesome, not interesting. Awesome.
Deferred execution.
That's right. Whatever it is I asked LINQ to do, it didn't just do it. Right here on what happened to my line numbers? We're gonna fix that,
but not whilst we're running.
Oh gosh. We're not going to fix it right now. All right. So right here is the definition of the action, not the execution of the action. It is really fascinating because it allows me to have yet another line. I could append to that, add another where, add now an order by, add and keep on going, and they all get applied when they are finally executed. Delayed execution is marvelous.
Is marvelous. So basically what we have there is a queryable object that each extension method is basically implementing queryable and returns a queryable, which then allows you to chain together multiple methods.
You're right.
Yep.
Yeah, no, you're right. I was just trying to pull up the queryable interface.
You didn't believe
me.
That's what it was. Yeah.
I did believe you. Of course I believed you. I knew it.
Stop bickering.
Dork.
So basically, that allows us to chain these things together, refine them, as you mentioned, add new wheres as we go on. We can also write services that return these queryables serialized across platforms and use different values. I actually did this an awful lot with Silverlight. Silverlight had a constrained version of LINQ implemented in it. Server side, I could actually build out a more complex LINQ statement and return it back, and then continue to append my LINQ queries client side and then evaluate the expression.
I think it's worth at least pointing out some terminology. There is an expression tree, and the expression tree is the entire query. And as you add a where, as you add an order by, as you add a select, you're appending to that expression tree that can get very complex, but that's how it's all managed,
right?
Inside this tree.
And you can actually directly manipulate the expression tree should you so wish. You may want to do this if you're building very complex inquiry screens in your applications, where you have a number of fields that a user can enter in to filter.
Right.
You can dynamically build out your LINQ query. By default, most of the queries append in an AND format. You may want to add something in an OR format that says whether it's this value or this value.
You're right.
The only way you can do that is by going in and directly manipulating the expression tree.
Not a trivial task, but it's there for you
if you wish to peel back the onion.
Yeah, that's right. There's plenty of blogs out there.
But remember, if you peel back onion skins, your eyes water.
They do.
They do.
They really do.
They really do.
Okay, so we have the same values here. Let's go to the next block here and talk about projection. So here, I'm going to take the same value, and look, it's really nice. What I'm going to return, it's just data. Remember, that's just that list of numbers. And I'm going to return a new object, an anonymous object. That doesn't have a name, doesn't have a direct definition. And I'm going to return 3 properties, whether or not it's even, whether or not it's odd, and what its original value is. Easy enough. So let me just jump to, let that be complete. I can look at projection. Here's the way we can go into that, and and when we look at the results here, did you know about this? When you are debugging, of course you did, of course, but I mean, did you know? It's a neat thing. I'm looking at the results here, and I always have to drill into it and see what the count is or whatever. And I can pin this so that I can jump right to it. And so I can. It's even more interesting when you look at values, right? If you look at like the count, for example, and so I can pin it right here. You can see it's right here. Every time I debug, that will always be shown, so I don't have to drill into that object again. Very powerful, very handy. And I can even do a little magical piece here, and I can say, this is the count, should never be more than 50. Right? Very, very cool. So this can be shipped to all my other developers that we work with on a team, but it's great also for me, right? When you're iterating through something and you have to click, 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 click.
Absolutely.
Okay, so now I've projected, and when I look at the type that's been projected, this list is no longer just a string, but it's a full-fledged object, and you can see it has 3 properties: even, odd, and value. Each of them have been correctly populated, like you would expect, and there is no name. Of course, we know the compiler does create a secret name behind the scenes, but we don't have to mess with that, and now we don't have to either mess with the definition or updating it if we never needed to alter it just to do this demo.
That's awesome.
Yeah, it really is neat. So let's look at the next one. So we're going to have a list of letters this time. A, C, B, E, Q. And of course, the point is they're out of order. We need to sort this. How are you going to sort an array? Well, prior to LINQ, it was a nightmare, right? Not that it couldn't be done.
Implement your own bubble sort? Or?
Yeah. And then if it's an array of an array, heavens, it's serious.
Fun, fun, fun.
Yeah, and so here we are. I'm ready. How are we going to sort this? Here's how we do it in the query syntax. So the query syntax, basically, from letters, from D and data. Wait a minute. From D and data. I'm sorting data instead of, that would have been so much more cool. I'll just make a change real quick.
Yeah, we'll stop debugging first, though.
All right here.
See, this is the value of pair programming if you've never tried it.
Yeah. Yeah. All right, perfect. Let me, I want to jump to here. I just put that so I'd know I was there. Okay, good. Yeah, I just didn't want to, I just need to visually see it.
Did you just do a breakpoint on your breakpoint?
I know, and it broke twice is what's funny, because it breaks before it breaks and then it breaks.
I know.
Anyway, so here I can sort ascending, right? That's a nice feature. So I can see now it's ABCD or ABCEQ, right? To make sure that everything's in order. And then I can sort descending, and you can see it's still there. One uses the QECBA, and one uses the query syntax, one uses the method syntax. Each is available to both, is really nice. I mean, just having order by, and you can do more. You can say order by, then by, and it does the next one. Now, these are complex sorting. All right, so here's a little bit more fun we can do. All of these, of course, we've used first, right? That allows me to get the very first. Really neat that we can do last. Go all the way to the end. I don't have to count first and then go to it and then go back one because it's ordinal.
Is that doing a shortcut, or did you think it's still moving all the way through the enumeration?
No, it's certainly not moving through the enumeration. It is. Ask me what you mean.
Basically, it looks like it's very short and a low-cost operation there, but the reality is it still has to evaluate your enumeration because it doesn't necessarily know, because it just has enumerable, so it has to move all the way through. So just because it looks like it's very simple and straightforward here doesn't necessarily mean that if you've got 10,000 items that it's going to know how to jump straight to the end.
That's right. These are helper methods that ultimately are doing what you would have done.
Yes.
Right? They don't have a secret backdoor to go do whatever it is that you want to. Now, so I can see that here's A, B, A, C, A, D, all in this list. All right, there it is. Looks really nice. And now I can go to distinct. This is a powerful one. Being able to do distinct, I use it all the time. And now I can see the results of distinct. A, B, C, D, that's what you would expect. It took out all the duplicates. That's really nice. And of course, it's really easy here to do a distinct, but we might have to pass in a custom comparator, thank you, that evaluates whether or not it is distinct or not, because it may be a deep object. And of course, here's first. We know what that does. First or default is really neat, because there may not be anything in there at all.
It may not be there, because if we're doing first and it doesn't find anything, what comes back?
Yeah, nothing. I mean, it's going to be a failure if you do first, right? Yep. Boom, there is no first. First or default comes back as null. But you can tell it what to bring back as well. Default for an integer is not null, right? It's negative.
So we need to move on.
Yeah, let's do. I want to talk about paging first, though, because it's probably one of the neatest parts of LINQ, and that's the ability to skip into a list and then create a page aside. So that's skip and take. Very valuable, very, very valuable. And then we have aggregate values as well, where we can use sum, min, max, average, different things like that would almost be, not impossible for sure, but just gobs of code in order to implement prior to LINQ.
So let's basically do a recap of what we've covered over the module. So, we obviously revisited our asynchronous activities and kind of talked about async, task and await.
That's right.
So visited that. Then we really spoke about how we can interact with databases and the type of technology that we have available to us and the patterns and practices that we can leverage. We also showed a fairly trivial interaction with the database, but we did demonstrate how quickly we could create a database and put some things up. Well, the real power of that particular local DB scenario is how quickly you can mock out a application. If you want to prove a concept, demonstrate some techniques, it's awesome. And then finally, we touched on LINQ, and we did a bit of a deeper dive into the LINQ capabilities, the types of methods and capabilities that it exposes out. Whew.
If we got paid by the word, we'd be millionaires right now.
Exactly.
No getting around it.
Here's hoping that your video playback does allow you to slow down the stream.
That's right. Okay, one more note. This is Microsoft Virtual Academy. This has been the Jumpstart for C# Fundamentals. That's course 70384. You can get the code that we've been going through out at xaml.codeplex.com. There's a Microsoft Virtual Academy link there that you can go and go through these with us, learn a little more. We have certainly many more demos that we didn't get to go through. There's so much to C#, Darren. We covered it so thinly. Honestly, it was embarrassing.
But we hope it was valuable. So it's goodbye from me, Darren May, and it's goodbye from him.
Jerry Nixon, jerrynixon.com, crank211.com for you.
Absolutely.
Have a good day.
See you guys again.